Alright, ladies and gentlemen, today we're going to go in reverse from what we did with multiplying our binomials using our algebra tiles. And now we're going to start with our quadratic function in standard form and reverse that. Start with the area model and determine if we can build a square or a rectangle, and whichever the case may be, what are those side lengths, both the length and the width, to create that area model. So let's review our algebra tiles. We know if we're looking at our large blue square, it has a length of x, a width of x, which gives us an area of x squared. Our skinny rectangle has a length of x, a width of 1, which gives us an area of x. And then our itty bitty square has a length of 1, a width of 1, which gives us an area of 1 square unit. And so we're looking at our quadratic term, x squared, and we're looking at our rectangle as our linear term, x, and our itty bitty square with the area of 1 as our constant. And as always, remember, if we are looking at a negative x squared, or a negative x, or a negative 1, then we will flip those tiles over and indicate negative with the color of red. Okay, perfect. Go ahead and make sure that you have the supplies that you need. You should have a record sheet for this geometric discovery. And I would encourage you to grab some markers or colored pencils and use that color to illuminate characteristics that will help you to find patterns as you work. We're going to look at the first two together. So let's start with our quadratic function in standard form. F of x equals x squared plus 2x plus 1. Go ahead and pull those tiles. X squared plus 2x plus 1. And once you have your tiles clear, go ahead and set up your grid. Use your expo marker, and on your table, get that crosshatch so that you can start to build your area model. Now we know that we put our quadratic term in the top left, and we put our constant in the bottom right, and then we'll fill in the rest of those spaces on the border with our rectangles. And so in this case, I'd be able to put one green rectangle here and the other down below. Okay, so in this case, with our x squared plus 2x plus 1, we were able to take those pieces to form the area of a square because my dimensions are the same. Now that's what we're looking at today, is to state the dimensions of your square or rectangle. And so we know that my length would be x plus 1, and my width would be x also plus 1. Got to have the same length and width if I'm building a square. Okay, so remember, today we're starting with the area pieces, building that model either as a square or a rectangle, and then going back to look at the dimensions of that shape to note the length and the width. Okay, so turn to your record sheet. And if we are looking at x squared plus 2x plus 1, this is the model that we've built. So let's go ahead and record that. I'm using 4x4 for the size of my x squared. And then I have two x's, which we lined up one to the right and one rectangle down below, which left us with our one constant itty bitty square in the lower right corner. Now, once you have your area model built, then you want to think back, right? We're starting from the inside and working our way back to those dimensions. What are we looking at for our length? This would have to be a length of x times x in order to produce that x squared. And since I only have one column to the right, then I'll have one itty bitty square. A positive x times a positive 1 would make that positive x. And same thing as I look down below, I have one row below my x squared, so I'll need one itty bitty square for that. Now let's think about what are the dimensions. My length is x plus 1, and my width, since I built a square, is also x plus 1. Okay, so let's see. We built a square, so go ahead and circle that, and then give me the side lengths. This would be f of x is equal to x plus 1 times x plus 1. Okay, let's try one more example together, and then I'm going to turn you loose for the rest of your functions in standard form. See if you can undo that with your algebra tiles. Okay, number 2, x squared minus 5x plus 4. So let's pull the correct tiles and clear this off. We need x squared plus 5x. Maybe that was a minus. Let me double check. Minus 5x. Good thing I double checked, huh? X squared minus 5x plus 4. And so these are all of the pieces that we have in our standard form for this quadratic function. So we want to use these pieces to build the area model. Either it's going to be a square or it's going to be a rectangle. As you're building today, you always want to try to build a square. Square's better, but if you can't, then look to see if you can build a rectangle, because that would be our next choice. Okay, so if we're going to build our area model, we know from our previous work that the x squared piece needs to start in the top left corner, and that we will build rectangles to the right and rectangles down below, and where they meet in that lower right hand corner would be our constants. So we have to decide, how am I going to arrange these constants so that I can fit in my rectangles? And this doesn't work because I still have an extra rectangle over. So building that square isn't going to quite cut it for me. So you just need to keep rearranging. Another option, instead of a 2 by 2 for our constants, would be a single row, a 1 by 4, and that would allow us to put one rectangle down below and 4 rectangles to the right. And so together, that's using all of our pieces, our x squared with all of our x's, all 5 of them, 4 to the right and just 1 down below. And then we have our positive 1 for each of our constants to get to a total of positive 4. Okay, perfect. Once you've built your square or rectangle, then you want to determine the length and the width. Give me the dimensions of that shape. So we know in order to build the x squared, that had to come from x times x. And then to line up one row down below, that means I'm going to have an itty bitty square. Now that's the question, is how am I going to get a negative? I'm doing a positive right now times a positive, but I'm supposed to get a negative x result. And since I know I needed a positive x squared and that these rectangles definitely need to be positive, looks like I better use a negative 1 instead, because a negative 1 times x would give me a negative x. Okay, so likewise, as I look across that very top row, I'm also getting a result of negative x's here. So I'm going to have to do x times a negative 1 to get this negative x. So 4 of these negative 1 pieces to get my width across the top. So really, my dimensions are x minus 1 times x minus 4. All right, let's go back and record x squared minus 5x plus 4 will arrange into a rectangle. Let's go ahead and record that. You can use any size that you want for your shapes. I just used a 4x4 for my x squared because I know it's all going to fit. Alright, so it looks like we have one of our negative x's to the right and 4 down below. So negative x, negative x, negative x, and negative x would give us a total of negative 4x. And then we have positive 1 for our itty-bitty squares and 4 of those to line up. And so that gives us our x squared minus 5x plus 4. Very good. So then looking at our dimensions, again we're going to have x times x to produce that x squared as our product when we multiply. And then in order to get a positive 1 for my constants in the corner, yet getting negative x's all along the way, I'm going to have a negative 1 times a negative 1 to produce that positive 1 here. Same way all the way down. 1, 1, 1, all negatives, and a negative 1 here. That way, as we're looking at our grid, we would have x times negative 1 would make a negative x. Okay, so looking at our dimensions, we have x minus 1 and x minus 4. And we want to record those in our side length blank. So f of x is equal to x minus 4 times x minus 1. And no, it does not matter which factor you list first. Your rectangle could have been rotated 90 degrees and it would still give you that same area model using the same pieces we started with. So no worries on that. Make sure that you are looking at your dimensions since they are not identical this time. We have built a rectangle instead of a square. Okay, so if you will continue with 3 through 8 and record and color code and highlight which one you built, either a square or a rectangle, and give me that side length, rewrite your function from standard form to intercept form where you can see those individual factors. Okay, and I want you looking for patterns. What do you notice that's similar? What's different? Can you compare each of these 8 and find some of those similarities and differences so that you're ready to tell me what you noticed and what you wonder when we continue tomorrow.